Have you ever wondered about the mysteries of numbers? There's a certain intrigue that surrounds them, a sense of mystery that has captivated minds for centuries. This is the world of number theory, a field that dives deep into the properties of numbers, particularly integers, and the myriad of topics related to them. Picture this: ancient civilizations puzzling over the complexities of numbers, laying the very foundations of this fascinating field. It was the Greeks who first identified the theory of numbers, setting the stage for a journey of discovery that continues to this day. Prime numbers, divisibility, congruences, these are but a few of the topics that number theory encompasses. Its simplicity, combined with its multidisciplinary nature, makes it a subject of great interest, not just to mathematicians, but to scientists as well. It's a field that continues to inspire, its influence reaching far beyond the realm of pure mathematics. Join us as we unravel the fascinating story of numbers and their secrets. Our journey begins in the ancient civilizations, where the first seeds of number theory were sown. Even before the advent of written language, our ancestors were already tinkering with numbers. They used sticks, stones, and other natural elements to keep track of time, seasons, and their possessions. These were the rudimentary beginnings of number theory, so deep in the human instinct to quantify and understand the world around us. In the cradle of civilization, the Babylonians and Egyptians took these early inklings of number theory and began to shape them into more formalized systems. The Babylonians, known for their astronomical prowess, developed a sexagesimal number system, which is the basis for our current measurements of time and angles. The Egyptians, on the other hand, were the first to explore fractions, developing a unique system that used only unit fractions, where the numerator is always 1. However, it was in Greece where the study of numbers truly took flight, setting the foundation for what we now call number theory. The Greeks were not just interested in using numbers for practical applications, they were fascinated by their intrinsic properties. They pondered over questions like, what makes a number prime? Can all numbers be expressed as the product of primes? This deep curiosity led to the birth of number theory. Among the Greek mathematicians, Pythagoras and his followers made significant contributions. They discovered the concept of perfect numbers and formulated the Pythagorean theorem, linking geometry with number theory. Euclid, another Greek mathematician, took things further by laying down the fundamentals of number theory in his work, Elements. His ingenious method of proving the infinitude of primes is still taught in classrooms today, over 2 millennia later. So, from the primal instinct to quantify through the Babylonian and Egyptian civilizations to the Greeks' formalization, the study of numbers evolved. Each civilization, each mathematician, added a piece to the puzzle, contributing to the grand tapestry that is number theory. The Greeks set the stage for the exploration of numbers, but the journey was far from over. As number theory evolved, it led to the discovery of key concepts and theorems. One of the most fundamental concepts in number theory is that of prime numbers. These are numbers greater than 1 that have only 2 positive divisors, 1 and themselves. The primes are the building blocks of the natural numbers, in the sense that every natural number is either a prime number or can be uniquely factored into primes. This is known as the fundamental theorem of arithmetic, a cornerstone of number theory. Alongside primes, another crucial concept is divisibility. This is the property of one number being able to divide another without leaving a remainder. Divisibility rules, like the rule of 3 or the rule of 11, provide quick ways to determine whether a number divides another, and they have been used for centuries to simplify calculations. Then we have congruences, a concept that was first introduced by the German mathematician Carl Friedrich Gauss in his book Disquisitiones Arithmetica. Congruences are a type of equation that deal with the remainder left when one number is divided by another. They have proven to be incredibly useful in many areas of mathematics, including solving Diophantine equations, which are equations seeking integer solutions. Speaking of equations, one can't forget Pythagoras' theorem, a cornerstone of geometry, but also a significant result in number theory. It tells us that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the other 2 sides. But did you know that it also leads to the concept of Pythagorean triples, sets of 3 positive integers that satisfy the theorem? These triples have been studied for millennia and have many fascinating properties. However, not all equations are as friendly as Pythagoras's. The French mathematician Pierre de Fermat famously scribbled in the margin of his book that he had a truly marvelous proof for what is now known as Fermat's last theorem, but he never wrote it down. The theorem states that there are no three positive integers that satisfy the equation a circumflex n plus b circumflex n equals sine c circumflex n for any integer value of n greater than 2. This claim remained unproven for over 300 years until it was finally proven by Andrew Wiles in 1994. These are just a few of the many concepts and theorems in number theory. Each one has contributed to our understanding of numbers and their properties. They've helped us to solve problems, to make calculations easier, and to find patterns and structures in the world of numbers. These discoveries and theorems have not just shaped number theory, but have found applications in diverse fields. They've been used in cryptography to keep our online transactions secure, in computer science to design efficient algorithms, and in pure mathematics to explore the infinite landscape of numbers. Truly, the influence of number theory reaches far beyond the realm of pure mathematics. From ancient civilizations to modern times, the study of numbers has undergone a remarkable transformation. Today, number theory stands as a testament to the ever-evolving human intellect, a field that thrives on the simplicity and elegance of numbers. Over the centuries, number theory has branched out, seeping into various disciplines. The ancient Greeks may have laid its foundations, but the true beauty of number theory is in its evolution. It's a living, breathing field of study, continually adapting and growing, much like the numbers it explores. Prime numbers, divisibility, congruences, concepts that originated in the realm of pure mathematics, have found homes in diverse fields. Cryptography, for instance, relies heavily on number theory. The security of our online transactions, the privacy of our digital communications, they all hinge on the properties of numbers. Computer science, too, has embraced number theory with open arms. Algorithms and data structures, the building blocks of computing, lean on the principles of number theory. Whether it's optimizing search algorithms or creating efficient data storage methods, number theory is at the core. In the field of pure mathematics, number theory continues to be a fountainhead of innovative ideas and concepts. It's a playground for mathematicians where they can experiment, discover, and push the boundaries of what we know about numbers. But what's truly remarkable is that despite centuries of study, number theory retains an air of mystery. There are still unsolved problems, uncharted territories, and unanswered questions. The Riemann hypothesis, the Goldbach conjecture, the twin prime conjecture, these are but a few of the mysteries that continue to baffle and intrigue mathematicians. These unsolved problems, however, are not a sign of failure. Rather, they represent the endless possibilities that lie within the study of numbers. They're a reminder that there's always something more to learn, something more to discover. Today, number theory continues to inspire and fascinate us, proving that the journey of numbers is far from over. So, what have we learned from our journey into the world of numbers? We've unearthed the intrigue of numbers and their peculiar properties, delving into the ancient and fundamental discipline of number theory. A field as old as the civilization of Greece, it was here that the theory of numbers first took root. We've traveled through time, witnessing the birth of number theory, a discipline that has grown and evolved over the centuries, always maintaining its central focus on the study of integers and related topics. We've seen how this seemingly simple study of numbers has paved the way for more complex mathematical developments, proving that simplicity can indeed be the mother of invention. Our journey took us to the key discoveries and theorems that have shaped the field of number theory. We've explored prime numbers, divisibility, congruences, and many other intriguing topics. Each one of these concepts has contributed to the richness and depth of number theory, demonstrating the multidisciplinary nature of this field. In our modern world, number theory is not just a historical curiosity. It has practical applications in various areas, including cryptography, computer science, and of course, pure mathematics. The theorems and concepts developed through the study of number theory are not just abstract ideas, but tools that help us solve real-world problems. As we've seen, number theory continues to be a source of fascination and inspiration for mathematicians and scientists around the globe. Its influence extends far beyond the realm of pure mathematics, touching many other scientific disciplines and even our everyday lives. So, as we wrap up our journey, let's remember that the world of numbers is vast and unending. Each number carries a story, a mystery, a puzzle waiting to be solved. As we continue to explore the mysteries of numbers, we can be sure that number theory will keep providing us with intriguing puzzles to solve and exciting discoveries to make.